All right, the second one says a rectangular lot, and if you're ready, you have the right answer for the first one. A rectangular lot is bordered on one side by a building and 3 other sides by 800 meters of fencing. Determine the area of the largest lot possible. Area. The largest lot means we're maximizing area. This is what's going in your Y1. Start with a diagram. You've got a building on one side and you want to fence this in. How do you want to label the sides? How did you label? X, X, Y? Oh, okay, either way you're going to come out with the same answers, just reverse. Remember to give me a let statement. X is the width and let Y be the length. Give me the let statements. Now, we know one piece of information, that all this fencing adds up to what? 800. So we can start like this. Just start like this. Easiest way. Combine these two. Okay so far? Now, the Y1 says this is where your area goes. This is what goes in your calculator. What is the area of a rectangle? Length times width, base times height, so X times Y. Now we need to replace this Y. So we come over here, we subtract the 2X, and we can substitute out Y. Now, take a minute here. When I distribute this, this gives me negative 2X squared. What's that going to give me? A parabola that opens down. And don't I want the maximum point? I want my maximum point. I want my parabola to open down. I want this to be my maximum point. Now, your window's not too bad here. So say we don't know where to start. If I just divide 800, God bless you, by 3, say I get like approximately 200. So I do 200 times 200. If X and X, say just they're all 200, just for instance. That's only 600. So say they're all 300. So 300 times 300 gives me 90,000. So start like that. Go to your calculator. Do your table set. Go by hundreds. Go by thousands. All you're looking for is where it's going to turn. You're not looking for the exact part. Did you guys get 200 and 400? Or no? You couldn't put this on your calculator? 80,000 is this point here. Excuse me, 80,000 is this, right? What does this represent? The area. This is your X value. This X has to come back in here.
How did you get the 80,000?
Well, you have to graph this in your calculator, so let's put this in your calculator. I hate using this thing because it's always like crazy. All right, so let's put this in our calculator. So we have X times what? 200 minus 2X? What was it? 800 minus 2X. Okay. Now I'll do it on this side. So now, let's guesstimate. Let's guesstimate where our window is going to be. Your minimums are zeros. My maximum X is where I want it to turn. So say X was 300. Say I took 800 and I just divided it by 3. I rounded it to 300. If I double 300, I get 600. So I'll make my X go to 600. I'm just, this one way to look at it. If I do 300 times 300, I get 90,000. So let me put my Y max at 90,000. Oh, this calculator is going to drive me crazy. I swear my board is haunted. Now, can I see it turn? Yeah, all I did was estimate. If I have a hard time estimating, go to your table. Now, set your tables to 100. Don't say, if you do it to 0. Okay, if you look at it, let me reset my table. If you look at it by 0 and 1, and you realize these numbers have to be kind of large because you're looking for area. Area is a lot larger than perimeter, right? Because we're multiplying, not adding. So if I notice that I'm increasing really kind of slowly and I got a long way to go here, just change your table set. Starting at 0, go by hundreds. Just to see where you are. All you need to do is watch it turn. From here to here, then I hit the ground. So somewhere like 80,000. So I take this 200 and I double it to 400. And I leave that at 80,000. If it doesn't work, I just change my windows again. So I say 400 and 80,000. And that should make me see it also. Now if I'm too close to the top, just expand your Y a little bit. Sometimes when you do this, it gets a little bit too close when it's exactly, because there's a little blank space up there. So just expand it a little bit more. Everybody can get to the window? And just do a max on this. Do your max. You want your maximum. Run your cursor to the left. Easiest way, just move that little flasher thing. Don't worry about the numbers on the bottom. And guess. There's your 200. There's your 80,000. This is from your Y1. That's why it's a good idea to start like this. What is my Y1? My Y1 is my area. So when I get to this, I say, oh yeah, there's my area. There's my maximum area. Okay? Question. Why did I keep going to what? The 400 comes from here. How do I get this X, right? But this is the X for here. Well, yeah. Oh, determine the area. I'm sorry. That's all you had to do. All you had to do was all you had to do was determine the area. But everybody knows you go back to here to get the Y, right? Okay. Good. You didn't have to go there. All right. You like these better, I'm assuming. Did everybody get?
I did it.
Okay, two non-negative numbers. So how do I start my left set statement? Positive, or it could be 0, right? And let Y equal the second non-negative number. Let's just say non-negative. Okay, whose sum is 9, so what statement is that? And so that the product of one number and the square of the other number is a maximum. So where do maximums go? Y1. So that the product of one number, product means what are we going to do? Multiply times what? The square of the second number.
Yeah, that's why I switched it to X squared and it made maximum.
You switched it to X squared?
And it has just an arbitrary number.
Okay, well let's try this and then we can always switch it around if we have to. Now, when I put this in my Y1, this is going to be my product in my Y1. My Y1 is my product. I got to get rid of this Y. So I come back here and I solve for Y. So I come in here and I say X, 9 minus X. When I get X times negative X, there's my parabola that opens down. There's my maximum. Square, thank you. There's my, oh, it's actually going to give you a cubing function. But you only want which quadrant? The first, because we made it be non-negative. Otherwise, yeah, it's probably coming from down here somewhere. Okay. So all you have to do is put this in your calculator. I would go back to a Zoom 6 since the numbers are not that large because you've been having crazy numbers here. And what did we put in here? X times. And all you care about is quadrant 1. And just do a Zoom 6. Start back to regular. Start back to a regular. You can kind of see it. It's going up there somewhere. And just change your window. Set your window to here. You're looking for the y to be a product. So the product should be pretty large, and I don't know where it's going to be. So I go to my table. I started at 0, go by 1s, because my x's are not that big, right? So 1 should do fine. I'm looking for this to increase, turn, and decrease. So I noticed it's in here somewhere. So I'm just going to double this, and there's my maximum. I'll make it 120. So I'm going to leave my x's, and I'm just going to make my y be 120. All you need to do is make sure you see this guy turn. If it's part of a thing here, all we care about is that one up there. Do a maximum, and you should get 3.
Yeah.
Well, x is 3 for me, if you did it this way. So I got x is 3. Come back to this guy, and y is 6.
Yeah, if you did it the other way, like, it just came out the opposite.
The opposite, that's all it is. Same thing like with the rectangles.
I have 3 and 108. Yeah, me too.
But you found this maximum, right? You found this maximum. What does this 108 represent? My y1, which is what? My product, or my cubic function. This is what's happening to you guys. Always start like this. What is my y1? My y1, just start with the words. My y1 is a product. So when I get this guy, this is a product. This is the x I want. This x goes back to this equation. Just start with the words first. Maybe that will kind of help you to see what that y1 is giving you.
This is sometimes the sum too.
The sum, we minimize, and we put that in y1. Generally, you maximize a product, you minimize a sum. Well, because if you think about an application like a fencing thing, you want to minimize what the cost is.
So you plug the 108 into...
Don't plug the 108 into anything. When you get this, you get this point, right? This 3 is your x value. This 108, just go like this. This is your y1. What is your y1? Your y1 is a product. I don't want my y1. It only asks me to find my 2 negative non-numbers. So I have to get this one and this one. Where did I find these? Right there. Go back to your let statement, Lily. That might help you. So what am I looking for? My 2 non-negative numbers. So there's my sum of my 2 non-negative numbers. So that 3 has to add to something else to give me 9. Those are my 2 non-negative numbers. My 108 is my maximum cube this time. And the last one, you didn't have the 4th? Okay. I thought we forgot. How is that possible? Okay. All right. I got another little review for you. I want you to take the first one when you see it, and I want you to graph it. Please. I just want you to graph it right now. Graph the first one. Go back to a Zoom 6. You need a regular graph. You guys will get more comfortable with your calculators. That's just a regular 10 by 10 graph. It's a standard graph. Oh, okay. You get to know our Zoom 6 is your regular negative 10 to positive 10. Zoom 5 is nice too if you want to get distortions out. But Zoom 6 works well. Oh, sure. Sorry, Lane. There was yours. Okay, just give me a graph of this. What's giving you grief? What's giving you graph regular.
This option is not working.
Oh, yeah. Sometimes what happens is some garbage gets set into this, and it just blocks something else from talking. So sometimes. Yes. Zoom. You go to the word Zoom. How do you guys go back to how do you usually go back to your? I reset it.
Yeah.
Just do Zoom 6. It resets it. That's why. Oh, that's probably why you look at me funny when I say when you mess it up. Just go back to Zoom 6.
Yeah.
Okay. So put this in your calculator and give me a graph. What's messing up your graph? It's an asymptote. We've got actually a couple, but the one that's outstanding to you is what part? It's the 3. Because where'd that come from? The denominator. God bless you. Where is your domain restriction for this? X can't be 3. So your domain says, well, jump over the 3, get it out of there. So, just so that you kind of, I like you to see the graph anyway. We know we have an asymptote right here. There's actually another one, and we didn't learn this yet, but you saw this also. You saw this also on that little worksheet that we did with the bubble thing. This is a y is equal to 2 when they're both the same, and it doesn't matter. It doesn't matter that you don't know that one. I want you to know this one because this is a domain restriction. But you can see that your graph did this. Somehow it broke up over here. Something else is happening right in here. See it? Something's forcing those ends to go the opposite way to do this. That's this. This is a y equals 2. So you've got an x equals 3 and a y equals 2. Okay. All I want you to do is find me the inverse equation. I don't want you to restrict any domains or anything. I just want you to find me the inverse equation. How do I find an inverse equation? Switch the x and the y. All the x. And then solve for y. An inverse notation is this. This is function notation. And this is for an inverse. The one thing that you guys have to know too is it's not always me being particular about the way you set these up and you write your notations. This follows you to calculus as well. So it's the 3 of us teachers, the 2 pre-calcs and the calculus teacher. We make sure our kids are doing the same thing all the way through. So when you get to calculus, you slide right into it and you don't relearn or you have to do anything differently. It is the same thing we do in pre-calc. My kids have a nice transition into calculus. Don't forget, you're coming from different Algebra 2 teachers that teach different ways. When you get to pre-calc, we all teach the same curriculum. We all teach it the same way. God bless you. Not this, no. This would be like increasing, decreasing, domain range, maximum point, vertex. We'll go over these. You did good on the first one. So, if you start like this, what's my first thing I want to do? Switch. That's these guys. I want to make this be the x. This is a y. This is a y. I have to solve for y. So now what? Cross multiply. Let's get that denominator out of there. I'm not going to be able to do this with a y in my numerator and a y in my denominator, and I certainly cannot cross out terms So right now I'm just going to cross multiply this guy. What next, Amani? Then you distribute. But now it looks a little worse, doesn't it? So when I need to solve for y, what should I do with all my y's? Get them to all one side, and then what can I do to my y's? Factor it out. Yep, factor it out. So either way you want to go with this, just get your y's to one side, get it to the other side. I'll bring this one over here if that's okay with you. So I get negative 3x is equal to 2y minus xy plus 3. You got what?
Oh, never mind.
Okay, I'm going to move my 3 over to the other side, if that's okay with you guys. So I isolate where my y is. I factor out my y. I didn't say this was going to look pretty. And I divide and get my y by itself. I write my function notation. Now, that really looks a little strange. I can't believe that's my inverse. So what should I do to check this?
I did it backwards and it looked better. Like I did the other.
Okay,
It's 3x plus 3 over x minus 2.
that's fine. You just factored out a negative 1. Yeah, you're fine. Yeah, you're fine. It'll work out the same. Now, how do I check this thing?
Don't you like that? You put it in the calculator.
Put it in your calculator. Put this in your y2. Now, it's still going to, you can put your y3, y equals x. It's still going to look a little different because of the way this is set up. So therefore, pick a value in your table. Pick an x, here's an x, y1, y2. Pick an xy value, listen carefully, pick one that doesn't have a fraction in it. Pick a nice value, interchange the two, and then that one should be here and here. You know what I'm saying? Your rule is xy swaps to yx. So when you do this, pick any set of values, then interchange them so that that y becomes your new x. And then that x should be over here. The rule should apply. One easy way to check. This one's not as easy to look at because of this. Because it's going to come right next to it. Because look where your y equals x goes. Isn't this almost symmetric over that line? So it's going to look a little bit different. And it interchanged your asymptotes a little bit. So just look at your table. Your table will help you out. Everybody find the point, swap it, see that it's there. Good way to check. Good. Any questions? Yeah, this was a weird looking one, but you still do the same rule. The rule doesn't change. Interchange your x and y, solve for y. When you have a whole lot of those things there, you're going to group them together, you're going to factor it out. Okay, now the next two I set up, these are the ones you're going to put in vertex form, and these are the ones you're going to graph without your calculator. So, because Gabby just raised her eyebrows at me, this is what I'm going to do. I'm going to let you use your calculator, yes, because they might have a fraction in it. So, I understand you might need to use your calculator for your fractions. I'm going to let you use a calculator, but don't forget, everything that you do has to be solved algebraically. So, the way I look at it, your calculator is probably just going to help you verify what you see as what you wanted to do. You wanted to be able to verify it. It isn't going to help you solve it, because I need to see all your algebraic work. So, agree on that part? Okay. Can we just put these in vertex form? So how do I get this in vertex form? What is my vertex form, by the way?
N parentheses x minus h of n squared. squared.
Good. And also remember, you're going to be given a point and asked to find the equation for it. I didn't put that on this extra review because I didn't think you needed any extra work with that. So when I do this, all I care about is my x's. And my coefficient of my highest one, my x squared, has to be a positive 1. So what should I factor out of here? Negative 1. So this becomes a positive. This becomes a positive. I'm going to complete the square. And I'm going to subtract whatever it is I added inside. Agree? If you need to put the 1 on the other side, put the 1 on the other side, add it to that side, and move it back after you're done. Are you getting a little bit more comfortable keeping it on one side? Okay. For vertex form, it's great. For roots, they're going on the other side. All right, so I use my rule. I take half of this. What's half of 4? So I do 2 squared is what? 4. Now, this negative, I'm just going to leave it a negative 1 if you don't mind. This negative 1, I have to factor out. I have to get that out of my parentheses there. So I distribute my negative 1. So this becomes a negative 4. What is 1 minus a negative 4? 5. So this is my equation. Which way is my parabola opening? That's a plus 2. Yes, I'm sorry. It's just kind of like that. Written over. Which way is this opening? Down. Don't lose that negative. If you don't bring down that negative, your parabola is going to open up. So don't forget whatever you factor out. That's why I wanted to put the 1 there. Sometimes those negatives just kind of like get lost. What's your vertex? Okay, so you're going to start graphing with negative 2, positive 5, and this is going to open down. Now, I don't know where this is going yet, so don't forget we're going to do all your intercepts algebraically. Y-intercept and the x-intercepts. Don't forget to do these. The x is nice, plug the 0 in. Just show me the substitution.
Will you, like, on the test, it'll say, like, everything?
Yes, it'll say everything. I just didn't list it all out, 'cause, yeah. So this one's the easiest one. Just show me the substitutions. Just say y is equal to 0 plus 0 plus 1. So there's your intercept. That's going to help me graph this, isn't it? So that I could sketch this. That's just going to help me give a sketch. My x-intercept, use this guy. So 0 equals negative 1 times x plus 2 squared plus 5. Subtract 5, divide by 1, take the square root, and give me your roots, okay? Also, domain, range, increasing, decreasing. Everybody okay with those things? All right. Let's get this out of here. This negative 1/2. Without your calculators. Without. So I'm just going to group these guys together right now. What should I factor out? A negative 1/2. If I take out a negative 1/2, this becomes a positive. Remember, when you took out a 2, you divided by 2. When you take out a 1/2, you divide by a 1/2. If I'm going to take something like 4 and divide it into halves, shouldn't I get a larger number? That's because your fraction says keep change flip. So what should this number be? 8x. So if I'm negative 4 divided by a 1/2, I keep the first one, I change to a multiply, and I flip the second one. If you think about it, if 4 has to be divided by 2, I get 2 parts. If 4 has to be divided into halves, I have to get more than 4, right? So that makes perfect sense. Then you're going to complete your square. Plus 1 and a minus something. The rest you're okay with? Here? Okay, just be careful of that fraction. I'm just trying to get through this so that you can work on it at home. I just want to make sure you're okay with this. Are you guys okay with using the increasing and decreasing?
Yes.
Okay.
Can you do the last one?
The last one. Well, let's do this one and then we can always go back to something else. So yes, you're going to do this one. So someone will take a minute and read this. And tell me what the first thing I should do is. Make a diagram. I like Anne Marie's idea. Make a diagram. Where am I? I've got a wall. I got a rectangle to be fenced in against my wall. I need two things. So therefore, don't forget your let statements. I know sometimes we breeze over these guys. But when you do, especially on a test, give me everything. So where do you want to label X? The width? And we'll label this the Y. Okay, what is it I'm maximizing? Area. So where is this going? So start like this. Y1 equals area. Lily, make sure you write this down.
Yeah, I did.
That's what's going to help you when you get that solution. And you find your point. Now, I've got to be given another piece of information. So they told me that the three sides of my fence total to 10,500 feet.
Yeah.
So what do I do with that?
10,500
Equals 2x plus y. Good. Kind of see the pattern here, right?
Yeah.
What's the formula for area of a rectangle? X times y. It's always x times y, even though you're missing one part there. It's still length times width. We've still got the rectangle. I got to get rid of this y. So I'm going to substitute out. I'm going to subtract this and solve for y and substitute it into here. Ah! Okay, so now, before you set your window, let's think about this for a second. The perimeter is pretty large. What did I say before? Just assume this is like a square. Divide it by 3. If I divide this by 3, just estimate. So 9,000 would give me 3,000 on each one, right? So it's a little more than 3,000. Let's say x is 4,000. Just x. Okay, just x is 4,000, my side. What's 4,000 times 4,000?
1,600.
A heck of a lot of zeros. 6 zeros. 6 zeros. 16 million. Try that.
Why?
In your Y max. How else can I do this if I'm not thinking that? Go to your table. And I certainly don't want to look at my tables by ones, right? What's a good way to look at my table? Hundreds. You could even try thousands. I don't know where this is going to be. I could try thousands. I could go by hundreds. Hundreds isn't too bad. All you're looking to see is as soon as that Y value turns, don't go any further. So you're only looking through really half of what you wanted to see. See if you can set your window up and find a point.
In the calculator, I just went to the windows, but I didn't the graph
Uh-huh.
table. See what notes it's like it changes in between 3,000 and 4,000.
Okay.
Is that like 187?
Right.
Is it 7? How many zeros are after it?
Well, so 187, what else does it say? E what?
187.
It says, wait. 1E7. What does this mean? Scientific notation. So 1, and it's going to move this decimal place. It's going to give you 7 zeros here. When you want to find the exact value, scroll over it. Like scroll over it because it's just putting a scientific notation there. See if you can set your window. I purposely made this one high, so you'd have to think about it.
Yeah, equinox are huge maximum.
Yeah, it should be, right? It should be bigger than that, maybe a little bit bigger than that, because we only estimated your x.
How do you know what the line max is?
Oh, I don't. So I just say, if I want to estimate this, how could I estimate these values? I could assume they're all the same, right? I could assume, because usually what we see a maximum, they get kind of close to each other. The larger ones don't really, but if I need a way to start, I'll just estimate that they'll be all the same. So I divided this by 3. And I just rounded it because I don't even want to sit there and take my calculator and divide. So it's between 9,000 and 12,000, right? And so it would be between 3,000 or 4,000. So I just estimated to 4,000. All I'm getting is a window. I'm not getting an exact measurement anywhere. My exact measurement comes when I do this. When I say max, that's where my exact measurement comes out. My window just says, just round this off to anything. I just need a starting point. I like to do my window before I look at my table. That's just the way I like to do it. So I like to estimate. Just figure they're all the same, 4,000. And 4,000 times 4,000 will give me 16 million. Could it be more than that? Absolutely. And I can go to my table. I certainly don't want to look by ones, but it gives me a good hint to say, if I go to my table, should I set it to hundreds? Should I set it to thousands? What should I set my table to? What kind of number am I looking for? If I'm looking for thousands, I might just say, set it to 1,000. From 0, jump to thousands, and see where you get. Did you come up with an answer?
13,781,250.
So, 13,781,250, something like that?
Yeah.
What was your X and your Y? I know, but what was your X and your Y?
2,625.
And what's your Y? That, take this, plug it in here, and this becomes 5,250. Yeah, I purposely did this just because I wanted you to play with these numbers. If I realize my X's are going to be thousands, I'm going to set my table to 1,000. But I don't realize it until I just estimate. Like, wow, that's a huge number. So I just take it and I divide it by 3. And I say, wow, I'm in the thousands. So start at my 0, go by thousands. And then what do I always say? Just reset by Zoom 6. Okay.